A woman can bike 30 miles in the same time that it takes her to jog 10 miles. If she can ride 10 miles per hour faster than she can jog, how fast can she jog? So we got two different rates that we're talking about in this problem. We have a rate of this woman jogging, which I'll call J. We have a rate of this person riding her bike, which I'll call B. So here's two different rates, jogging and biking, right? And I know something about these two rates and how they relate to each other. I know that she can ride her bike 10 miles per hour faster than she can jog. So if I take the rate at which she jogs and add 10 to it, I get out the rate at which she bikes. Okay. I know something else, right? I know that in some amount of time she bikes 30 miles, and in the same amount of time she could jog 10 miles. I don't know how long that time is. I'll just call it t. But I know that if I take the rate at which she jogs, multiply it by t, I get the distance, 10. I know if I take the rate at which she bikes, multiply it by t, I get that distance, 30. So I know some things about J and B in relation to the time t, right? Ultimately, I'm interested in how fast she can jog. Right? So I'm interested in maybe solving for J at some point. So here's an equation. Why don't we take it and solve for J? Right? So J equals, how do we solve for J? I'll divide both sides by t. So 10 over t, that's what J is equal to. Of course, I don't know much about t. I do know one thing about t. Here's the one other thing, besides this one. Here's the one other thing I know about t. Let's take this and say solve for t. All right, so I can go ahead and divide both sides by b, and I get t equals 30 over b. Right? So I can replace this t with 30 over b. So I have 10 divided by 30 over b. Complex fraction, I don't like complex fractions. Let's go ahead before I complicate this anymore and get rid of the b in the denominator here by multiplying by b. To multiply by b in the denominator, got to multiply by a b in the numerator, so those guys cancel. And we're left with 10 over 30. That is 1 over 3. And a b in the numerator, so we'll have a b over 3. So J equals b over 3. We've gotten somewhere. I know something else. Let's get rid of this b by using that equation. Right? B is equal to J plus 10 divided by 3. So I have J equals J plus 10 over 3. Rational expression. I know how to solve these. I'll get rid of my denominator again. So I'm going to multiply both sides of this thing by 3. The 3 is going to cancel over here. On this side, I'll have a 3j. So I have 3j equals j plus 10. Subtract j from both sides. Subtract j from here, it goes away. Subtract j from here, I have a 2j. So I'm going to have a 2j equals 10. Divide by 2, j equals 5. So the rate at which this woman jogs is 5 miles per hour in this case. So that's our answer, 5. She bikes 10 miles faster, so she's going to bike at 15 miles per hour. From that, we could even figure out, how long this mystery amount of time was, right? If she's biking at 15 miles per hour and she went 30 miles, that means that she had to be biking for 2 hours. Or similarly, right, if she was jogging at 5 miles per hour and she made 10 miles, she was jogging for 2 hours, right? So that time would equal to, well, this problem didn't ask us for that. So J equals 5, that's the rate at which she can jog.